哎 ，Hello， 大家好，有声音吗？等一下，我分享一下复制连接。有声音吗？有声音吗 ？Hello， 有声音吗？
讲话的时候可能就是嘴巴都不动。
大家有听到我的声音吗？看一下哦。
是啊，这个主持人长得漂亮，但很卖哦。
哎，嘉熙，午安啊，早安呐，应该说早安呐，有声音了啊。阿义，早安呐，战恨早安呐。我们今天来到一个非常炫炮的一个现场。就是这个 GeForce 的 LAN Party， 对 ，GeForce LAN Party。然后晚一点10点半的时候，还有那个 Nvidia 的执行长黄仁勋，他会进行演讲。早安，大家早安。没有，我先带大家来看一下整个的现场，好不好？整个现场，对。那我首先在会场的。很长，直播会场的后面，给大家看一下。直播会场，音乐是蛮小声。这边还可以。哎，前面这边的话有一个舞台。现在这个舞台是正在抽奖，正在抽奖，差一点加油！在有奖征答。是什么？哎呦。然后主持人是目前看起来是实况组平捧。好，然后。这边的话，全部都是实况组的位置，差一点哦。所以你如果在，我刚看了一下，应该比较多是在那个有吗？可以吗？Twitch开的。来，请说。我进去给大家看一下，好不好？进去给大家看一下。哦，直落2，哇！太强了！到底有没有？你这个耳机里面有没有音乐啊？看。这边直接就可以看到人家在开实况，我以为他说音乐，这个是在开神魔之塔的实况，不哦，太大了！这边直接我实况人家的实况，而且是从背后实况，恭喜来，我们一点往前一点，给大家看一下。我们要来，2位转过来面对观众，我们准备来颁奖了，好不好？来，我们有参加奖啊，也有获胜的奖，那我们就先评评可以帮忙。来颁个奖，我们有 等一下是10点半那个演讲这样，
笔记本，
俊斌很懂，
还有厚背包，然后这个包包，哇，这太帅了吧！哇，超想要！来，我们拍张照，来，先看中间，官方摄影师，好，笑容哦，好，笑容好吃。我们这边动态来一个，然后对着它摇一摇你手上的礼物，跟动动。ROG， 要大喊 ROG 哦！来3、2、1 ，ROG！ 耶！好，来，恭喜2位！恭喜！来，2位可以先稍作休息。你好玩吗？很好玩好玩，对不对？这边好，我们继续玩。有，我们有多准备。舞台的前面就是那个。为了让大家都觉得很好玩，我们就多玩几题，好不好？好，来，那我们就准备好了。那老师，请再帮我切出这个精美的画面。这边的话就是舞台前面就是直播区。好，我们没有，我们后面就不用再。可以哈，可以。啊，不要这么难。很多人都可以啦，对。而且给大家看一下这边的这个来实况的实况组，大家真的都是各种火力支援。你看这种 RGB 的。来，你想选哪一位？主机。赞到，来，第1位，好来，我们这边现场是蛮暗的了，所以我不知道说实况大家看不看得清楚。然后刚刚我看到一台主机非常屌，给大家看一下。它的主机是长这样子，有没有看到？它上面还有一个钥匙，然后有点类似飞剑，然后还有那个飞弹钮。这是一台电脑，超级猛。我说什么？这个很漂亮。我觉得我的电脑主机真的是太朴素了。他们才是真正的电脑玩家，他们连电脑都非常的都玩得非常出色，你知道吗？不是就只有玩游戏而已。酷哈。现场的话应该是看起来应该有上百位的实况组，而且现在已经有人在实况了，超厉害的。现在已经有人在实况了。早上台啊！哇，这一题好难。他说，如果以后真的我也来这边的话，那真的就是要爆肝了，因为他们是3天的时间。1比0，加油来！
这个电脑可以钓鱼，可以啦，它这个都直接炸鱼了。好，这边有点太嗨了，我们去一下那个
好长，
闯关区好不好？我们去一下闯关区。因为这边的话是舞台区跟实况区这样子。好，接下来我们去。
哇，下一题，哇，等一下。
那去舞台区，要去那个闯关区之前，先来看一下这个展示。这边的话有展示2个蛮帅的东西。看一下他手上那一张纸。这个题目谁出的？好快！
全自动制程技术。
大家有没有认出来这个是什么东西？很酷哦，给大家看一下哦。这个是超基数空服竞技版，做的超级帅的空服竞技版。这是一台电脑，对，这是一台电脑。这个是显卡嘛？然后这个应该也是，好像也是显卡，双显卡这样子。如果你电脑是长这样子的话，应该开机之后什么事情都不想做了，就看他在那边转就好了。好，然后旁边的话就是我们有玩过的游戏，《黑神话：悟空》里面的盔甲，但是这个应该是大圣形态的吧？应该是大圣形态的。
请上台，好来再来一位哦，好来换边，好换边，好准备好了。
上面它还有那个头箍。
好来，我们请这个品牌它的来选一位，来你选一位。
细节做得非常好。
好来，就是你，来请上台。2位。
然后刚刚稍早之前也有活动有访问这个作者。我真的觉得说，台湾这种手工匠人啊，或者是职人，真的是非常厉害，尤其是在做游戏这一块的。
我们先来确认一下，这个他们是真的听不到声音，好不好？来，
我觉得他们应该是做的比游戏还好，游戏里面的呈现还好。因为有些玩家你电脑没那么好，可能没办法呈现这么好的细节。然后这个是黑神话悟空甲，马克制造的哦。马克制造。良知的各位，你如果现在是有空的，你们也可以来到现场。这边是北流文化馆，然后这边就是闯关区了哦，就是有各家厂牌，你可以闯关。虽然这个是 Aeros， 但闯关之后，他们是有可以抽奖的。我刚刚已经都闯完了，所以说我就拍给大家看。你只要闯关。体验这一个，比如说 Aeros 好了，你就体验他们的设备，玩一下游戏，那你就可以盖章，然后盖3个章就可以抽奖。看一下他们现在的Aeros 这边的摊位，看一下。然后这边有，看你在实况。好酷哦！直接专业的哦，我直接无形实况人家的实况。
这里觉得有一个置顶贴文，这里肯定有一些什么
东西。好赞哦！你们有看过实况？那个不稀奇。你有看过实况组正在实况当中吗？
我自己去被电。
因为他在玩的游戏好像是。那种多人生存的，然后旁边的话是在玩那个 POE， 这个摊位是 Gigabyte 的笔电，然后再来这个摊位是那个 ROG 的 ROG。这个体验。参加活动吗？我有参加过了，参加过了。我还可以玩蜘蛛人。可以玩蜘蛛人，要玩看吗？不用，我现在也没有手可以玩。谢谢。可惜了。显卡没像刚才那样会动。对，它自己。这些的显卡都是用到最顶的。 40系列的，而且等一下那个 Nvidia 的执行长他会演讲，不知道会不会带来一些新的东西。然后这个牌子是罗技的哦，我的装备都是整套罗技的，给大家看一下。这个是滑鼠、耳机还有键盘哦。他们这个罗技它还有出一个云端游戏掌机。这个大家如果要进来体验的话是不需要门票的，你现在来可以。对，但是等一下10点半的时候会有演讲，所以你也可以看完演讲再来。因为他9点，我记得我是9点半到的啦，然后来的时候因为很早，然后又是平日，所以说基本上是不需要那个排队。好，然后这个摊位是 MSI， 这个 MSI 的火龙，帅，旁边这个，然后 MSI 的摊位的话，你是可以去体验他们的笔电，现在的笔电真的是做得很好。
是电竞笔电？哦，只是电竞。
我以前一开始也都是用笔电在实况，真的笔电的效能越来越强，会不会到最后用笔电，然后外接一些萤幕，这样子是当成是桌垫。然后MSI 这边还有一个摊位，这边的话就是桌垫的，这里就是桌垫。这边也有展示说体验的设备的规格。这台跟我差不多。然后手把体验格斗游戏，哦，可以耶，肉眼可见的顺畅，赞哦。再来的话是 NZXT 啊 ，NZXT， 它的这个 NZXT 比较是电脑的周边。哦，我看到一个重点。这个拍得出来吗？好酷哦！它那个字定是那个乌萨奇，拍给大家看一下。这个烧到我。好赞！所以它现场的摊位其实蛮多的。我们这样看过来的话，有1、2、3、4、5、6、7个了。它还没结束哦，还没结束哦。这边还有那个 Robotics 的，对，没错，这边都是NVIDIA。对。哇，这边直接展示了6块显卡，好赞哦！而且它的这个显卡看起来，因为我对于显卡的就40系列的印象就是它很厚，像我的那个40系它也就蛮厚，但是他们这个看下来就还 OK。现在科技进步了，但看起来还是蛮重的。跨界还好啦，你都电脑用那么久了，这边也是可以玩那个黑神话悟空。好，再来的话是那个 FSD 啊，这个我忘记叫什么了，因为我的机壳好像是他们的，有点忘记了。这边的是啊全汉，对啦，全汉。好，谢谢。对啦，我的电工呢，就是这个。之前用1块2的烧掉，然后现在用全汉用到现在。他们的那个电工是真的很赞。OK， 电工
是那个自己家的哦，自己家的。
Made in 台湾的，推荐大家这个电工。好，再来小，因为等一下要黄仁勋要演讲，所以说会有很多布置的那个荧幕。等一下整个场地都可以看到他的演讲画面。好，这个是最后一个摊位了哦。它也是有笔电，然后跟桌垫这样。哇，我只能说台湾玩家非常幸福，有非常多的那个电脑配备可以选择，超级多。我们直接无情拍到一些漂亮的画面。好，现在几点了？现在是几点？我看一下。哦，再10分钟，再10分钟。然后这边是有战旗的实况副文，各式各样的游戏都有。然后这个应该看起来是，应该是 Overwatch。对，我们看完了那个闯关区之后，接下来我们再回到实况区，然后舞台。对，整个的会场就是大概这样呈现一个正方形，舞台区，然后实况区，然后接下来刚刚的一个展览2个作品这样子。有人钓鱼吗？我刚刚没看到哦。我想说奇怪，但是后来想说，对啦，你应该也不会那个人不在的时候挂着自己的手机游戏这样子，所以可能有些那个实况的位置，它没有实况组，它可能人在的时候它才会开来钓鱼嘛。像这边的话，这3个位置就空的，3个位置是空的。那它的这个实况组的部分，实况区的部分也都是有比如说 MSI 啊，然后 ROG 啊、雷蛇之类的。如果是刚进来的朋友，我再带大家进去看看啊。这个实况区的部分。
你说他们在现场是要怎样？不能拿实况组不然。
我看一下它总共是有几区哦，因为它其实都有标记说比如说这是8区，然后这是9区这样子。我看一下总共有几区哦，因为我刚刚没有仔细数。这边的话是第14区啊，第14区。好，然后还可以再往后，我看这边萤幕超级大，超赞。12，然后13，所以总共就是14区这样子。14区，一区大概3到5个实况组，3到5个实况组。OK。这个实况组他在玩的游戏蛮酷的呢。有没有观众知道这是什么游戏？这好像是有点益智类型的游戏。嘿嘿，真有趣。而且其实现在看大家都是背对的，所以我其实也是看不出来谁是谁，因为会来到这边的实况组通常都是蛮知名的，蛮知名的。这个看起来是有点类似那种街机啊，应有吧，应该算是。看一下，真的耶，看他秀一波。但这个一定要听耳机。因为现在看下来是没有放出来的，音乐是没有放出来的。因为这边正对舞台啊，你音乐放出来的话，你也没办法听得清楚。好，开秀咯。 然后这边的话也有专业的实况组，它是有打灯的。哇，在这么暗的状态下，真的是需要打灯，不然的话，我刚刚看的几个实况组他们用的镜头，你今天如果是没有打灯的话，其实你可能就只看得到鼻子，就五官而已，你的头发什么的其实就看不太到，其实就看不太到。然后这边的话也有在拍整个实况，然后还有直接视讯没有玩游戏的。对，给大家看一下。现在看起来蛮多的，还是在玩 POE2啊，最近还是比较夯一点。今天是 GeForce LAN 50的最后一天。哦，一般玩家是可以进来，一般观众可以进来，不用买票。所以你们如果现在有空的话，你可以来北流文化馆这边来进行闯关，又或者是看一下很炫炮的展示品。好，我找一个地方好好来看一下那个 Nvidia 执行长的演讲。哦，这边的话是全汉电工还蛮赞的哦。其实现场的女性实况组比例好多哦，比例真的很多。我基本上看下来应该是50-50哦。这个 Llama 比想象中的还香哦。
NVIDIA 执行长黄仁勋 CES 主题演讲就要正式开始啦，请大家尽速来到舞台前方或者摊位区的大荧幕前方来就坐。那除了这个是两个地方之外，我们在后面休息区也可以一起观看，所以请大家赶快找个好位置，因为我们将会随时开始进行抽奖。今天所有奖项中奖人要现场马上上台领取哦。主持人比较没耐心，所以唱名会很快，请大家一定要保持在舞台周遭或者是摊位区的周遭，我才能够看到你举手哦。然后那也提醒大家，待会电子设备记得要静音，不然等一下如果大家看到一半，只有你一个人的电话响起来，会好尴尬，好不好？来，那就请大家赶快移动脚步喽。
好赞哦！我看一下哦，舞台区前很多人，那我就再找一下，我要在哪里看？因为我觉得站着看是 OK 啦。我怕挡到别人。只想要看妹子。来，恭喜！这个虽然说看起来暗暗的，但是妹子，来算几个妹子。然后这个4个全部都是，好不好？还不来现场？然后这边的话，
再次提醒大家，我们以舞台区前方为优先哦，舞台区前方为优先，请大家优先到舞台前方的摇滚区来就坐。那这个四面八方都可以坐。如果说是 BYOC 的玩家的话，在玩家区里面
有其他直播组去
的。然后大家如果要把椅子作为这个转移，
这边实况区全部都实况组啊。刚刚算了一下，应该
打个好位置，我们马上就要一起来看直播啦。
应该50-60位哦，50-60位哦。
先跟大家预告一下，今天我们的奖项总共有12个、8个，还有我们奖项有超过20个哦，但是一定要现场领奖。那先跟大家说一下稍后抽奖规则。
这边有点那个，
我们除了现场要马上
我还是进去好了
之外，BYOC 的玩家要带着识别证加证件，如果是一般民众的话，要带证件，要一起上台哦，好吗？那如果说上台之后说我忘了带，那我只会给你1分钟，所以请大家务必要带在身上啦。然后直播马上要开始了，还有1分钟左右的时间，请大家赶快往舞台前方靠近。另外也要记得将您的电子设备静音哦。
好， 好，我在这边，因为这边
好，那也请目前站在走道上、厕所跟电梯前方走道上的大家，我们可以到合作伙伴摊位区。摊位区也准备了2台大电视，请大家现在立刻马上开始移动脚步，我们到摊位区来收看，好不好？我们到摊位区来收看。
这边是北流，
大家赶快动起来！
来，文化馆。
好，各位，如果不赶快移动的话，我要过去找你们喽，我很可怕的哦。
再来看一下，
大家不要站着，你们这样罚站，我们良心会痛痛的耶，好不好？大家不要罚站了，坐下。你们要坐这边还是要去合作伙伴那边坐都可以。
但是我自己
坐下来看，
觉得还好。我自己的主题全部都是暗的那些的。没有，我不算有名，我只是路过了一般观众而已。
好，如果是现场合作伙伴、工作人员，或者是其他就是不是这个观众朋友的所有工作人员，今天是来上班的各位，我们也尽量先不要站在走道区，因为我们会有不同判断玩家朋友跟民众朋友们是否有找到位置。
我去摊位区好了，因为这边比较暗，我去摊位区。来，去摊位区。那个主持人不是。现在舞台区太多人了，我们去摊位区。对啊，这边还比较亮一点，然后这边也有，这边不错。
好，来，我们请大家可以移动到这个合作伙伴的摊位区，
然后那边也是有，
来，我们移到
所以说不是说大家就只有舞台区可以看的，因为舞台区那边我们刚刚在的那个实况区跟舞台区那边比较多走道，然后我想说我不要站在走道那边。
听得到吗？我们到摊位区，谢谢。
来看一下，今天那个 Nvidia 执行长黄仁勋会带给我们什么样的惊喜？可以啦，大家现在都还可以过来啊！我坐着好了，啊，席地而坐。哎，你们应该听得到声音吧？就是主持人讲话或者是那个演讲的声音。因为它上面有一颗喇叭，蛮大的。
好，后面的玩家朋友或者是观众朋友们，我们到摊位区，
那等一下演讲的时候我就不讲话了。
到摊位区就坐。来，各位帅哥们，来右转。
这边刚好就是我们刚刚介绍的那个摊位区。
来，各位右手边，
有没有？
来右手边。
这样子。然后直接在这边架一个萤幕。哎，我们刚刚走过去的时候，这个萤幕还没有看到。对啊。哎，不知道说这个。
好，来，现在在舞台侧边的，如果大家等一下觉得看眼睛快要变斜视了，随时欢迎移到摊位区。
网络上也可以看到。
好，来，
感觉这边是全球实况哦。
右转直走到底。
对。这边的话都是电脑配备啦的厂商啊
，Aeros 啊，报道区的工作人员也帮我引导一下，
然后 ROG 啊，这些都是比较
舞台区现在已经只剩下看完会显示的位置了。
电竞产品啊，当然这一次的这个主要还是 NVIDIA。啊，这个你们如果是对于笔电或者是电脑，现在想要换的，你们应该就知道这些牌子。而且我觉得现场它是没有什么 show girl 之类的，对，所以说你如果是想要看 show girl， 这边没有，只不过有很多美眉实况组。我刚刚去那个实况区寻了一下，比例应该有50-50哦，因为总共大概快50位吧。然后刚看过去至少20位女生。 但还好啦，这个主要是你不是在网络上看实况，你是在他后面看他实况，这个蛮有趣的。这边是一般民众也可以免费进来的，在北流的文化馆，蛮好找的因为北流就那几栋大的建筑物，比较靠近那个忠孝东路。AI 教父，没有他应该不是亲自来现场，应该不是。开始喽。
CES isn't just about what's next. It's about what's possible. And when technology and humanity intersect, the answer is anything. That's because tech doesn't just solve challenges. It transforms them into opportunities. It helps us move smarter, live healthier, and experience the world in ways we never thought possible. We are not just here for a tech event. We're here to connect, to solve, to discover, together. Tech isn't just advancing, it's uniting, bringing us closer to an autonomous future, connecting us to better care, making life more connected, more dynamic, and more human. Today's challenges demand bold solutions, and CES is where they start to take shape. Breakthroughs in sustainability, advancements to help feed our growing world. This week isn't just a stage for breakthroughs, it's the spark for discovery. Every screen, every pixel, every part of the tech you will see here showcases the extraordinary potential of human ingenuity meeting technological power. Now we begin this celebration of what connects us, has the power to solve our greatest challenges, and offers endless possibilities we're yet to discover. Right here, right now, the world is watching. So let's dive in.
哦，现场啊，现场啊。
Ladies and gentlemen, welcome
应该
to
是
CES
现场转播的。
2025. I'm Gary Shapiro, CEO and Vice Chairman of the Consumer Technology Association, the producer of CES, and I am so thrilled to kick off this show with a keynote by one of the most consequential companies in the world. NVIDIA exemplifies the cutting-edge innovation we celebrate at CES. And founder and CEO Jensen Huang is a true visionary, demonstrating the power of ideas, technology, and conviction to drive innovation and reshape our industry and our society. I always like to say that if I'd listened a little bit more closely the last time Jensen spoke at a CTA event, I could have retired already. But over the past 3 decades, he has established NVIDIA as a force driving change across the globe in industries ranging from healthcare to automotive and entertainment. Today, NVIDIA is pioneering breakthroughs in AI and accelerated computing that touch nearly every person and every business. Thanks to his leadership, NVIDIA's innovations enable advanced chatbots, robots, software-defined vehicles, huge virtual worlds, hyper-synchronized factory floors, and so much more. Huang has been named the world's best CEO by Fortune and The Economist, as well as one of Time Magazine's 100 most influential people in the world. But you know, the fact is, like for all of us in this room, our success and his success was not preordained. Jensen started out working at a Denny's as a dishwasher and a busboy, so be nice to them in the future. And he said that the lessons he's learned there, the value of hard work, humility, and hospitality, are what helped him keep the faith and persevere through some of NVIDIA's early challenges. In just a few minutes, We'll hear from NVIDIA founder and CEO Jensen Huang on his unwavering vision of the future and where we're headed next. Stay tuned and have a great CES.
好，开场讲完，应该准备要那个咯。感觉这边应该是，它这个应该有点像是那个新品发表会的感觉，我觉得吧。之前的大巨蛋有看过他本人，算是见证传奇的人物。刚刚主持人有说，那个我们现在现场北流的现场还会有抽奖，不知道等一下会抽什么。太快了，一大串，一下子就换页。他应该是叫现场的人不要那个手机不要开声音，然后不要有那个闪光。40系列之前刚出来的时候，那个时候挖矿还很兴盛呢。
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier,
the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Only light up.
Thank you, Adam.
And give us peace of mind when we need it most.
Hi, Moroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
They bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life. What we've lost.
Zachary, I got my voice back, buddy.
They help us move forward, one small step at a time. And one giant leap together.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
今天的皮衣很帅哦，比较亮一点。
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it. Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA. You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993. Ready, go! With NV1, we wanted to build computers that could do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtua Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 years 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Kershevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application can be inferred. And so when you see application after applications that are AI driven, AI native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now. computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at an incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look. Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron. 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is a brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. So the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled, fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549.
也太便宜了吧，1/3的价钱，507的修它。
Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale availability starting June. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1,299, this 5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is look at this thing. Here. There's only so many pockets. Ladies and gentlemen, Janine Paul. Woo-hoo. So can you imagine? You get this incredible graphics card here, Blackwell. I'm going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family. Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at NVIDIA. This is literally our office. This is literally NVIDIA's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling laws says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think that in the next couple of years humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data can be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and difficult problem that is verifiable functionally, and has an answer that we understand. Maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate. Your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some, every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that Janine? You know, it's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second, is this a good idea? All right. Wait for it. Wait for it. I thought I was worthy. Apparently, Yoyer didn't think I was worthy. All right. This is my show and tell. This is show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons. 600,000 parts. Approximately equal to 20 cars. 120 kilowatts. It has a spine behind it that connects all of these GPUs together. 2 miles of copper cable. 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, we use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that can be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry guys. You see that? That's cool. Look at that, disco lights in here. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this, I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can, thank you, thanks. Boy, is there a chair I can sit down for a second? Can I have a Michelob Ultra? How is it possible that we're in Michelob Ultra Stadium? It's like coming to NVIDIA and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models, and these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens can be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is Agentic AI. Agentic AI basically is a perfect example of test time scaling. It's a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it is maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools, it might be using a calculator, and it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build agentic AI. NVIDIA NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, Tensor RTLM, Triton, all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you can take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud, because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or they might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company, the business process is different, the way you work is different. So you would give them examples of what the work product should look like, and they would try to generate it, and you would give a feedback, and then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do, these are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Neotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tuned them using our expertise and our capabilities, and we turn them into the Llama Neotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super, Llama Neotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model can be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not. Basically give feedback to other models. It could be distilled in a lot of different ways. Basically a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work being done at ServiceNow, at SAP, at Siemens, for industrial AI. Cadence is doing great work, Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant AI application, next giant AI service, period, is software coding. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents. AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's Agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Neotron vision language models, Llama Neotron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes,
and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization.
Okay. That was the first pitch at a baseball. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI was created in the cloud for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud, it's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have, in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs. Generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we developed that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation, digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you. Linux is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is, this model in the middle is quite large, it has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically, and it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we need a Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it's so incredibly effective, computationally demanding. What if instead of it's your surrounding, and what if instead of the prompt, a question, it's a request? You go over there and pick up that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GBT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something and falls to the ground, if you poke at it and it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios. then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things.
我看一下，我先去舞台那边看看。
Fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand.
那个显卡超级便宜，然后现在机器人那个的话，
there are many downstream things that we
以后就不能玩仓库翻了。
do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically plausible scenarios of the future. Basically, do a Dr. Strange.
然后舞台这边的话， 正在转播那个黄仁勋的演讲。那我刚刚是在体验区啊。
could do, of course, caption, and so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots as well as large language models. And so this is the NVIDIA Cosmos. The platform has an algorithmic model for real-time applications, has a diffusion model for a very high-quality image generation, this incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principal physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth.
有观众知道这是什么游戏吗？
Combination of the two
竟然可以玩
gives you a physically simulated, a physically grounded multiverse generator. And the application and the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus
这样子看下来，他的演讲应该大概1个小时左右，1个小时半左右，差不多。
Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that
录进了几个实况组的画面，因为他们刚刚在切那个实况画面，然后发现他们视讯后面都站着我，好好笑。
But to connect the two, you need a digital twin.
出现在别人的
This
实
is
况
all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. You know, instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA robotics. So let me give you 3 examples. All right. So the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically is the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. We're partnering with Keynote, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have. Through the developers and ecosystem partners, we have just a growing number of ecosystem partners connected to Omniverse. And the reason for that is very clear. Everybody wants to visualize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that. This one example that we're doing with Keynote and Accenture. Keynote, the supply chain solution company. Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Keynote is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Keynote's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations
and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Keon can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Keon and Accenture are reinventing industrial autonomy.
The future, that's incredible. Everything is a simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers, the training systems, the training AIs, the simulation systems, and the synthetic data generation systems, Omniverse, and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world. Waymo and Zoox and Tesla, of course, in their data center. BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs. Just so many cool companies. Lucid and Rivian and Xiaomi and of course Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming out. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate of about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here.
哇，这个应该是蛮多人好奇的。
Okay, this is Thor. This is Thor.
这个是新的汽车的晶片。
This is a robotics computer.
哇。
This is a robotics computer. It takes sensors and just madness amount of sensor information. Process it, umpteen cameras, high resolution, radars, lidars. They're all coming into this chip, and this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a human or robot, it could be the brain, it could be the manipulator.
它真的就是 AI 全开的，软体、硬体、汽车什么的。
The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. the only and the highest. And so I'm really, really proud of this. ASIL-D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, NVIDIA CUDA, yeah. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play. The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers. NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replay drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario. With Cosmos Neotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective cores, setting the standard for safe and advanced autonomous driving. Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate or plausible so that we can have an enormous amount of data training. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. I think the next part is robotics. So
humanoid robots， 钢铁人的环节，对不对？
my friends. The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers, so long as they can accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars, and the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of cars, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical AI-embodied robots. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to port up into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T built on Omniverse and Cosmos for domain randomization and 3D to real estate. Generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Synth before deploying to the real robot. The age of general robotics is arriving. Powered by NVIDIA Isaac GR00T.
We're going to have mountains of data to train robots with. NVIDIA Isaac GR00T. NVIDIA Isaac GR00T. this is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of the NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously it revolutionized artificial intelligence computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned at the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And you know, you know, imagine, ladies and gentlemen, our
他真的拿了，他怎么变的？他真的拿了，哇
This is NVIDIA's latest AI supercomputer.
秀了一波，超级电脑，超级小。
And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, you know, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB200, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. Isn't just so cute? And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Grace CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connected with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. So it's coming at you. It's just incredible what we can do, and it's just, I think it's really. I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything. Because you know it's a cloud platform, it's a cloud computing platform that sits on your desk.
以后电脑就这么小台。
If you would like to have double digits, this is what it looks like. And you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits.
这应该是它的大绝招了，超级电脑。
Okay.
又来了。
Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model. The world's first physical AI foundation model is open, available to activate the world's industries, robotics and such. And three robots working on Agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please.
哦，结束了。哦，厉害厉害！要来抽奖了。抽奖，不知道这次会抽什么。对，它的话，我用这样子。我刚刚看的，虽然说都是英文啊，但是加减听啊，主要是新的显卡。新的显卡，它50系列5070，500多块美金的话，大概2万，对，大概2万台币。 然后你可以获得4090的效能，这个是蛮可怕的，对。然后机器人啊，又或者是汽车 AI 那种的话，我觉得这个东西是已知的科技，然后会越来越进步，我觉得是正常的。嗯，然后它的那个有一个部分我听不太懂，就是它的那个虚拟人，什么 Nemo 那个我就听不太懂，对，所以就期待一下，说之后会不会有那个中文版的。 因为我们看完之后，啊，还有一个超级电脑啊，对啊，但是那个超级电脑它也没有讲价格，而且感觉超级电脑应该也不会用在那个家用这样子。我现在在那个 GeForce 的现场，对 GeForce 现场，然后刚看完黄仁勋的演讲，然后现在待会会有那个抽奖，等一下来看一下。 他的抽奖的奖品是什么？而且我有参加抽奖，我看一下我能不能够欧洲，对，看一下能不能欧洲。好，他现在还在播放那个，我看一下。就是刚刚的那个总结啦，他们还在播放他刚刚的总结影片，蛮猛的嘞。因为我觉得他以为他演讲大概1个小时。 就是他东西讲蛮多的。哎，还没结束吗
？Have a great CES, everybody！
哎，他要出来了。
Thank you。
又他跑出来，结束了吗？ 哦，结束了。
真是太精彩了！哇，刚才的影片有没有让大家有点鸡皮疙瘩的感觉呢？是的，我们刚才已经一同收看完了这一场精彩的直播。那么接下来，请大家把注意力回到现场的舞台上，有请 Alan。
大家好，我是 Nvidia 亚太区 PM Alan。我想，Blackwell 应该是我们 Nvidia 在全部架构里面最知名的架构。
好的，这个对不起，让我打个岔一下。我想说，你打完招呼之后，大家应该会鼓掌久一点，然后让我有机会可以插个嘴。我们可以从鼓掌的地方重来吗？好，来鼓掌，很棒。好的，那接下来呢？因为我觉得这个看起来好像掌声有点不是那么厚实，因为我们有一半的人现在还在伙伴区，对不对？请在伙伴区收看的各位好朋友们，现在赶快移动脚步回到舞台前方。
就像我们刚
好的，那时间再次交还给 Alan，有请。
好，谢谢主持人。那我想 Blackwell 像刚刚讲，这应该是我们 Nvidia 有史以来最知名的一个 GPU 架构。为什么呢？因为我想各位可能除了各位玩家的爸爸妈妈，连我去摩斯都听到隔壁的阿姨在讲，那个 Nvidia 的 Blackwell， 它在那个 AI 多厉害，打造了一个最强的 AI 晶片。那我觉得身为玩家，我觉得最高兴的一件事情是。Blackwell 终于也降临在我们的 GeForce 的 GPU 显卡上面，对不对？对，没错。我想刚通过 Jason 介绍，我们的 Blackwell 架构也降临在我们的50系列上面，打造一款最强的游戏显示卡。那刚刚Jason 介绍的，里面包含了920亿个电晶体。那里面不管是我们的显存变成 GDDR7， 或者是我们有全新设计的。RT 光追扣，还有我们全新设计的 CUDA 扣和 Tensor 扣，我想这些通过这些全新的架构，我们都提升了效能高达2倍以上的一个效能。那这个是在 GPU 部分。那另外在软体部分，我想刚刚 Jason 也提到了，我们有发展出了下一代的 DLSS 4的一个软体。那透过我们 DLSS 4的神经网络，透过我们的 AI， 可以高达8倍以上的一个FPS 的一个提升。让玩家在游玩的时间，在不失画质之下，有更好的、更流畅的一个 FPS 一个表现。我想最后应该是玩家最关心的一点，就是像刚刚 Jason 有介绍的，我们可以用 RTS 5070 549美金的价格，买到等同现在4090 1500块。1599美金的相同效能，哇，这是玩家应该觉得最高兴、最乐意见到的一件事情，对不对？对。好，那最后在这边，因为老讲我们 Nvidia 真的很感谢各位，其实各位大可以在家里面坐在电脑前面、坐在电视前面看直播，那很高兴各位可以特别来到这个会场。参与我们这是 Keynote 的一个直播活动，所以我们这边特别准备一个小小的惊喜给大家。那我们现在请我们同仁把这位惊喜呈现给大家。那同一时间，我们也欢迎台湾区协理 Ace 来一同上台，为我们揭开这个惊喜给大家。
好的，接下来我们准备了，这是什么？要变魔术了吗？是什么呢？好的，有请 Alan 和 Alex 来到
什么东西？
惊喜的两侧，两位请先手持布幕，稍后听我口令，请全场跟我一起倒数3秒钟。两位请听到请揭幕的时候，为我们正式揭开面纱。大家都准备好了吗？好的，倒数3、2、1，请揭幕。是的 ，GeForce RTX 5080正式降临现场。5080在哪里？我没看到，好多人啊！各位现在舞台上看到的就是搭载着 Blackwell 架构的 GeForce RTX 5080。现在先请大会摄影师为我们捕捉一下5080的真面目。哇，各位啊，期待已久了。刚才看那个从美国送来的讯号啊，不够过瘾啊！今天实体来到现场，让各位欣赏一下。这一次我们比 GeForce RTX 4090快2倍，全世界在第一时间能够看到的，除了其他3场的 GeForce LAN 之外，就是现场各位玩家朋友们了。看到他本卡了。我们爱 下侧面给大家看。因为其实呢，它除了具有多画格生成功能的 NVIDIA DLSS 4，可以把画格速率提升8倍之外，还能够透过 NVIDIA Reflex 2把延迟减少75%，透过 NVIDIA RTX 神经着色器等，还能够为游戏玩家和创作者们提供最佳的游戏视觉沉浸式体验。另外，为什么要特别转侧面给大家看呢？因为你们看一下，它是不是非常的轻薄？它比 GeForce RTX 50系列创始版显示卡还要轻薄非常多，采用的是顶级材料来打造，外形独特，搭载创新散热技术，提供超厉害的效能表现以及超强的稳定性，每个细节都是精心设计而来，采用了革命性的新型双风流设计创新技术，加上液态金属散热界面材料，还有独特的3片式 PCB， 可以提高冷却能力和功能，让大家能够享受到安静的冷却效果，同时无损内部高效能的 Blackwell GPU。好的，我们官方摄影师是否都已经捕捉完毕了？
通常不是都是买那个。
好，那我们就请现场的好朋友们也可以开始来尽情的捕捉。
这个算是原卡。
是的，在我们舞台上的就是5080。
因为刚刚焦距拉很大，所以说很陡，所以我就不放大了。
要来抽出，所以请大家拍摄完毕之后，也不要先急着离开舞台前方哦。请大家呢拍摄完毕之后可以蹲下，让后面的机器能够拍得到画面就好了。
20几个奖项。
好，现场的大家要捕捉画面的，赶快加紧脚步喽！稍后我们也要请全场的好朋友们，我们一起跟5080来一张大合照，好不好啊？哇，好兴奋哦！好想把玻璃罩打开，但是不行。
人蛮多的。
好，但是我们这一次那个帮大家准备的4面8方都能够拍摄得到的，而且光线打得也非常好。好，我们现在看起来这个目前舞台前方还有2机正在拍摄。好，那我们如果前方的摄影师都拍摄完毕了，我们就要准备来张大合照喽，各位。好，来请全场所有的玩家、所有的好朋友们，来请大家可以先起立。好，因为如果说太低的话，我们等一下拍起来会脸太小，拍不到大家。好，请大家全体通通有，请起立，来到舞台前方。好，现在我们舞台前方摇滚区还可以再进来更多人，请侧面的大家也走到摇滚区里面来。同时呢，待会我们也可以马上开始一起抽奖啦。好，来各位，我们准备好了。好，现在就请 Alan 回到舞台上，这边我们也邀请 Alex 还有 Andy 一同来到舞台上，跟全场所有的好朋友们一起来张大合照。好，那待会我们从台上往下拍的同时，请大家手机可以先放下来，因为不然的话就拍不到你的脸，拍到你的手机而已，好不好？好，来各位准备好了。好，3位长官，我们跟全场的好朋友们一起来张大合照。好，可能3位要稍微围蹲啊，很好很好。哇，要蹲这么帅就对了，这样我们后面大家会相形逊色，大家不能输啊，摆出你最帅的 pose。好，来各位看向前方的镜头。好，我们先自然笑容来一张。然后来，摄影师不要互相干扰，台上太多台了。好，
最新的显卡在这边。
来，各位，我们准备好这个调整好位置之后呢，就要开始来正式合影哦。好，请大家全体通通有灿烂的笑容看向台上的摄影师。好，3、2、1，笑容保持定格一下下哦，再来一张定格哦，定格。好，看头上有手在挥的，再来我们一起比个5。好，全体通通有，我们比出一个5，不要挡住自己的脸喽。好，笑容保持，再定格一下下，再1秒钟，再2秒钟，我们定格3秒钟就好了，再撑一下。好，来换一台，打下一台是动态吗？来动态，请大家待会帮我挥挥手，灿烂的笑容。好，手要低一点，不要挡到自己的脸哦。好，笑容，看向摄影师，耶，挥手挥手。好，我们是人体动动哦，自己要一直动，不要停。好，来。 好的，我们还没有下一集，有吗？没有 ，OK 了，都 OK 了。好，来，接下来好。我们要把这个展座先移开，我们只有人的来一张，好不好？因为展座有一点高，待会呢我们来一张只有拍到大家的。感谢大家陪伴我们整整3天50个小时的时间。这一场嘉年华，除了大家最万众瞩目的全新发表之外，其实更重要的是有各位与我们同在的精神。好，那现在就请3位长官，我们再次好稍微蹲在舞台上。好，那我们一样请摄影师来帮我们捕捉。好，来，首先是平面，好，请定格比出一个5。好，笑容保持哦，笑容记得。好，再来一张，再加油一下下，再定格一下下。好，也很棒。接下来是动态的时间，请大家5先收起来，5先藏起来。我们现在先变0，好，5先变0，5先藏起来。好，待会我们那个摄影师镜头一开始动的时候，我们就把5拿出来，好不好？好，来准备好了，好，来3、2、1，走，很棒耶！好的，再次请大家给自己一个热情的掌声。感谢大家支持我们一起好吃好玩50个小时，也谢谢3位长官可以先稍作休息。同时，我们也更感谢所有的合作伙伴们带来的产品与体验。NVIDIA GeForce LAN台北为了感谢现场的玩家朋友们，接下来我们马上就要来抽出价值30万元的产品们啦。好的，那我们现在先来准备一下舞台的同时呢，好，我们要进行抽奖。先来跟大家重新说明一下抽奖规则。待会抽奖的人，请问是台上领奖还是台下领奖？台上。好，来，请问要带什么？证件，没错。那如果是 BYOC 玩家，除了证件还要带识别证，很棒哇！大家随堂考都100分。那待会呢，首先我们要来抽出的是我们会分为2大群组来进行抽奖。首先我们要抽出的是今天有在早上9点半之前完成签到的一般观众朋友们。好的，我们赶快来公布一下奖项。好 ，BYOC 玩家的奖项稍待片刻，我们在第2个群组当中会把它抽出来。好，我们先来公开一下奖项。好的，那我们当然，先回到上一页一下，帮我回到上一页一下，我们来看一下。是的，我们这一次有这么多的合作伙伴热情的来共襄盛举，可不可以给他们一个掌声？耶！感谢合作伙伴们，也是整整3天陪伴我们。好的，那接下来我们就要来公布一下一般观众的奖项，有请。好的，待会呢我们会有这么多整整12样。好，来，大家想先抽哪一个？有没有想先抽哪一个？先抽哪一个？喊数字，几号？2号是不是？先抽2号是不是？好，来，那我们就先来抽出Stuff Gaming GeForce RTX 4070台 Super 显示卡1张。好的，来点欢呼声，耶！好，来，我们先进入到这个2号，没错，4070台 Super 就是这一个看一下哦，我们有完成签到的名字通通在这里了，我们要准备抽奖了，请抽奖。好的，系统公平公正公开，我们抽出的是，恭喜曾慧明325在哪里？举手，你在哪？曾慧明325在哪里？在哪里？4070台显卡在哪里？举手哦。好，来，要唱名3次喽，不在现场唱名3次，我们就重抽喽。好，来，曾慧明1次，他不要，他圈出来，你确定？确定。好，来，曾慧明1次，曾慧明2次，曾慧明3次。好，来，我们重抽。谢谢慧明，慧明好大方哦。好，我们再来一次。好，恭喜中奖的是李慧勋226，李慧勋在哪里？举手。恭喜，你在哪？尖叫好大声，但是我找不到，在哪里？在哪里？举手跟我挥挥手，在这里。恭喜你！来，慧勋来，各位。那个待会帮我调整一下好不好？楼梯口帮我留一个小通道，等一下有人要上楼梯的时候帮我指引一下好不好？不然大家找不到楼梯在哪里。来，慧勋有没有带有带这个证件吗？那我来检查一下。好，来1位工作人员到我这一侧来帮我检查好不好？我们稍后一起拍，我们稍后全体一起拍。 好，来一位工作人员可以来我这一侧帮我检查证件，然后我核对一下。好的，慧勋很棒。好，来这里。好，来，那你在台上稍后一下啊，我检查完了 ，OK 的。好，来，接下来我们要抽出下一个奖项。好，来，接着请问大家，来，我们看一下，想要先抽哪一个？要先抽荧幕，还是显卡，还是笔电，还是先抽笔电？是不是？好，来，我们先抽 Lenovo 的这个 GeForce RTX 4050的 B 字型电脑一台。笔电，请抽奖。拜托。好的，到底会降落谁家呢？恭喜中奖的是陈冠宇，来，请上台。来这边请，来找工作人员核对证件，好的，来，恭喜他。好，接下来下一个奖项，想抽什么？要先抽什么？先抽机壳是不是？好，来，我们先抽 NZXT H7 Flow 机壳。好，请抽奖。好，看一下会抽中谁呢？恭喜这位幸运儿是王俊尧，192王俊尧在哪里？举手，在这里。来，找工作人员核对一下证件，恭喜。好，来继续进入到下一个奖项，请问想要抽哪一个嘞？抽哪一个？耳机是不是？耳机跟键盘是不是？我们先拿耳机好，耳机在上面。好，来先抽罗技 Pro。无线 Pro X 无线电竞耳机 V2 白色一台，请抽奖。好，我发现我靠太近会看不懂字。好，来，请问是哪一位呢？恭喜曾慧明，慧明有在吗？慧明到底有没有在？
这个是第二次，
他不在是不是？
第二次中太爽了吧！
他确定不在哦。好，来，那我们就直接重抽啊，来重抽一次。好的，无线电竞耳机，请抽奖。好，恭喜中奖的是简志宇。简志宇在哪里？请举手。在哪里？简志宇这个，在后面，来，赶快到前面来找工作人员核对一下证件。好，那我们紧接着要抽出下一个奖项。好，想抽哪一个？刚刚说键盘是不是？要先抽哪一台？要先抽那个罗技的还是雷蛇的？罗技的先好不好？来，罗技的无线机械式电竞键盘 Pro X TKL 桃色。好，来请抽奖。好的，现在要抽出的是键盘的得主，恭喜徐启祥。徐启祥在哪里？请举手。他的朋友帮他欢呼一下，在这里，恭喜！来找工作人员核对一下证件。接下来，好，还有一把键盘，对不对？那我们就接着抽喽。好，来 Razer 的 Death Stalker V2 Pro 键盘。好的，请抽奖。好，这个奖项总共会有3位幸运儿。
有显卡，然后又有
恭喜尤耀廷491尤耀廷。来，请到右前方找工作人员核对证件，恭喜你。好，接着我们继续抽出。好，第二把，恭喜获奖的是范云轩，恭喜，在哪里？举个手，哪一位？耶，幸运儿！来，好，接着我们抽出第3位。第3位可以获得雷蛇键盘的是。恭喜高赞富，恭喜！核对一下证件。好，接下来下一个奖项。好，大家想要先抽什么嘞？我们还有显卡、荧幕。先抽电源没有问题啊！来，全汉 FSP Vita GM MIT 1000瓦2台，首先抽出第1台，请抽奖。好，恭喜！中奖的是简焕松，恭喜！来，我们右前方。好，接下来紧接着继续抽出第2台。好的，这个我们昨天在舞台活动有介绍过啊，前天在舞台活动有介绍过哦。好，来恭喜黄福天在哪边？
剩下2个，
举手让我看一下。
剩下2个奖项。
在哪一个？好啊，恭喜！好的，接下来好要抽哪一个？抽显卡，抽荧幕。荧幕先是不是？好，来 Predator 32寸 Mini LED 电竞荧幕。好，来马上抽出1位幸运儿，请抽奖。 好，恭喜这位幸运儿，中奖的是戴廷宇，恭喜你！来，赶快来前面，赶快来前面，恭喜！好，接着下一个奖项。显卡是不是？然后来抽出 Gigabyte GeForce RTX 4070代 Super Gaming OC 16G 显示卡，请抽奖。
好像是，没有，它是 Super 的 ，Super 就不是。
恭喜中奖的是童冠成，请举手，恭喜你！来带上你的证件。好，下一个奖项我们马不停蹄继续抽出。
还有吗？
好，要抽哪一个嘞？我们抽完了吗？抽完了，哎呦，抽完了，很棒。来，恭喜刚才我们获奖的12位。那我们接下来系统要进行切换。好，那接下来呢？来，请问刚才我们的12位全部都核对完毕了吗？全部都核对完毕了。好的，那我们就请大家依序上台。来，就按照最靠近阶梯的顺序就好。来，请上台。好，第一位到我这边。好，我们就顺着排一整排，好不好？顺着排一整排，看能排几位，能排几位就排几位。好，大家要在同一个水平线上哦，同一个水平线上。哎，为什么有人特别后面？往前一点。好，来，好，那不够站的我们站前面，来站前排。不够站的站前排。好，来，剩下的来帮我站前排。好，我们分成2排站。好，来到这里就好，到这里就好。好，来，往你的左边一点，往你的左边一点。好，来，还有吗？来，哦，小心手机要送给舞台了。来，站前排，好不好？来，你到第一排。来，好，灰衣服很想站第一排，你也站第一排。好，来，那我们女生也站第一排，好不好？好，来，那我们全体通通有，来，我们通通往中间聚拢。摄影师帮我们调整一下，第一排是不是要往左边？往左边一点，对不对？来，往左边一点。好，来，第2排自己自动找洞钻，好不好？找2颗头的中间。好，来，请大家看向前方镜头，我们送上拍照板。好，来，接下来我们就请Andy 帮我们颁奖。耶！没有。直接就是。NVIDIA 亚太区产品总监 Andy。好的耶，恭喜各位！好，来，全体通通有，请从右手边下台，我们要来签名哦，好吧？要来签名。好，来找工作人员签名。那接下来啊，我们要准备来签名啊！来，等一下，稍等一下。好，签名到哪边？好，我们找工作人员来签名。好，那接下来我们要继续来抽出的是 BYOC 玩家们的奖项。好，来各位先借我过一下啊，没关系，我腿比较长，我直接上来了。好，接着抽出 BYOC 的奖项，总共有8样，帮我们下一张。好，简报帮我下一张。好的，包含有笔电、电源、水冷、实况截取盒、电竞耳机，还有电竞键盘，通通有。那我们就按照顺序来依序抽出啦。好，请进入抽奖画面。好的，那我们接下来要进入到抽奖系统的画面中。好的。那我们稍后呢将会抽出有ASUS TUF Gaming A15 GeForce RTX 4050笔电，还有 MSI Katana 17 GeForce RTX 3050笔电，还有 FSP 的 V8GM MIT 1000瓦2个，还有 NZXT Kraken Elite 360 RGB 水冷1个，还有 NZXT 的实况截取盒 HD60 Logitech Pro X 无线电竞耳机 V2， 还有这个 TKL 无线机械式电竞键盘。好，那我们就马上开始抽奖。
这个我不会被抽到。
好，我们就从第一个开始抽出，首先抽出ASUS 笔电1台，请抽奖。
实况组是谁？
好，来，记得是识别证跟证件都要带哦，各位玩家。好，恭喜钟敏琪吗？这个字怎么念？琪吗？还是新？好了，没有人要告诉我。来，中奖人在哪里？在哪里？举手。好，来，请到舞台右前方来核对证件，带上你的识别证。下一个奖项继续抽。好，请抽奖。好，微星的笔电，恭喜中奖的是。恭喜 杨俊尧举手来右前方，恭喜你。紧接着下一个奖项，让我们来抽出店员2位。好，来，首先第1位，恭喜中奖的是郭梦琪，恭喜，请到右前方。紧接着第2位，
这个有开心，这个有开心。
第2位同样可以获得电源。恭喜，中奖的是蔡佑生，请举手，来，请到右前方。好，紧接着要抽出 NZXT 的水冷1位。好，恭喜中奖的是谁呢？恭喜吴子硕，恭喜，请上台。好，我们请到右前方。好，下一个是实况接水盒，请抽奖。好，来，恭喜中奖的是张家祥，举手，在哪里？在哪里？请举手恭喜。好的，来，请到右前方核对证件。下一个奖项Logitech Pro X 的无线电竞耳机1位。好，恭喜中奖的是林敬伦，恭喜，我看到手了，很棒。好，来，接下来下一个奖项，
不知道等一下还有没有抽。
好，要抽出的是无线机械式电竞键盘，请抽奖。是的，今天我们这个准备的非常多的奖项我刚刚有说是超过20个所以大家应该还可以来期待一下。廖家辉来右前方来核对证件。好的，恭喜以上8位。好，各位幸运的玩家们，来，请大家这个帮我核对完证件之后，帮我列队，好不好？列队，8位应该是可以站得下的，8位应该是可以站得下的。好，来，如果已经这个好，
可能不到2万台。
来，如果已经核对完毕了，我们就可以陆续上台。好，核对完毕了吗？请上台。好，接下来我们要请 Alex 来帮我们颁发奖项。然后来，各位中奖者 ，Go， 赶快上台，来。好，请上台。好，一个跟着一个，来 ，Go。
都没有女生。
好，接下来我们请 Nvidia 台湾区业务协理 Alex 来帮我们颁发，有请。好，我们一起看向前方摄影师。好，笑容保持，我们一起比个5，耶！恭喜各位幸运的玩家朋友们，恭喜！好的 ，Alex， 请留步。来，玩家朋友们，请从左边，好不好？请从左边。那我们要稍微跟着工作人员稍等一下。好，我们旁边先集合，稍等一下，因为前一批还没有写完资料。好的，那接下来呢 ，Alex 被留下来的，应该就知道要发生什么事情了。来，请问大家，还没中奖的在哪里？
要加码了！
还没中奖的尖叫声！各位，恭喜你们！虽然没有中奖，但是不用灰心。新的一年 ，NVIDIA 给你新的、更多的期待。所以接下来呢 ，Alex 来，我们像左右门神一样，来到荧幕的2边，一人一边。好，来，各位，请看大荧幕。没错，加码时间，最后的 B150超级限定有3位。超级幸运的玩家朋友可以获得 GeForce RTX 5090创始版，想不想要？想要的尖叫声！好的，来，谁给你们最多的期待？耶，很棒啊！摄影师有录到吧？有没有录到？要把他们录下来。哇，这个群情，来，等一下，再一次。来，摄影师直接到中间。来，谁给你们最多的期待？ 我就报名了，早上我来上什么班，我就应该来报名啊！哎呀，好的，那我们接下来就要准备来抽出了，请大家跟我们一起倒数3、2、1之后，一起大声的说 GeForce LAN 50，然后我们的系统就会启动抽奖了，准备好了吗，大家？来，倒数3、2、1 ，GeForce LAN 50，请抽奖！哦呦，紧张刺激，紧张刺激，是谁？是谁？是谁？哎呦，放这多次，周全燕，来，直接上台，直接上台，直接上台，来我旁边，来，先秀一下，秀一下，哇，5090的，全球第1位了，太扯了，太扯了，太扯了，哇，来，不够大声！我们今天的第1位超级幸运儿啊，来，接下来抽出第2位，请抽奖。
来看一下啊。
好紧张，好害怕，好刺激，是谁？是谁？是谁？周全成，请上台，在哪里？他在哪里？哦，看到他狂奔了，来，赶快上台！好，那我们工作人员上台来帮我们核对一下，证件有带吗？赶快，我们先请工作人员来核对一下。来，2位请上台，恭喜！来，你的我帮你看，你的我帮你看。哎呀，恭喜俊彦呐！好，来，千成来，请上台，恭喜2位！耶
！5090大概6、7万吧。刚刚看他写2000美金，2000美金，2000美金，哇！这个现场这个兴奋程度。
好，这个在发之前啊，我要特别讲一下这个，因为现在目前我们卡还没有上市，刚刚发布而已，所以等到上市之后呢，各位就可以这2位非常非常幸运的这 gamer 呢，就可以从里面拿出绝无仅有的这个卡片，绝无仅有哦！我来公司15年，从来没看到这种礼物哦。后面会有兑奖序号跟网站，然后直接兑奖。你们就在第一时间拿到5090创始版显卡，各位。哇！ OK。
好，来，那我们就赶快来合影一下喽。哎，这个 Windows 的牌还是要拿的，好不好？来，我们先独照，是不是？好，来先独照一下。 好，来，我们跟你们说一件很重要的事情，幸运儿，来，我们要重拍，因为我们这盒子可以给它打开，好不好？来，打开秀出来，好不好？打开秀出来，哎呦，绝无仅有就算了，还这么好看。来，2位，我教你们拿一下，来这样子，我们往前这样子拿，好不好？来，好，这盖子往后稍微凹一点，对，好，来，我们再重拍一次，独照先来一张，好，来，2位都独照，来，2位先各自独照一下。 好，来哦，站的，好，来 ，Alex， 请到中间。哇，好想要哦，可不可以？我也有一张，但是不能兑换，没关系，太帅了，我也想要。哇，来出悠游卡好了，出个悠游卡。哇，太幸运了，恭喜2位，耶！再次给他们一个热情的掌声。恭喜2位超级幸运儿。 耶！来，哇，他们现在开始小组会议了，偷听一下讲什么。哎呀，留到最后，站得最久的，对不对？来，戏台下站久了就是你的，我们还真的是戏台，对不对？哇，太棒了！来，恭喜2位。那我们一样旁边先找工作人员。 来，2位先找工作人员，稍微冷静一下，因为我们这个兑换事项也是非常重要的，必须要告诉你，好不好？啊，来，也谢谢 Alex， 也谢谢大家现场所有的好朋友们以及玩家朋友们对于我们这一次 NVIDIA GeForce LAN 50台北的支持，感谢大家。那我们这次的活动圆满成功，请大家给我们一个欢呼声，耶！非常期待下一次的活动再跟大家见面啦。那提醒各位，我们稍后呢将会在。 好，来，我们接下来呢，请大家在离场前先帮我们填写一下问卷调查。跟你们说， 问卷这种东西啊，只要看到满意度问卷，一定要填哦啊！可是要认真填，不要全部都说很好、很赞而已。后面那个意见的地方不要空白，你有想法就要告诉我们，因为我们真的会看，好不好？我们不是说哎呦 KPI 那问卷要100份怎么样的，我们是真的有看哦，好不好？所以你们要认真填哦，好吗？这样子我们才可以每一次活动都更好玩，每一次都让大家更
体验就到这边了。
好，那在大家填写的同时，提醒各位，场地要在2点整关闭，并且清场。
希望之后有机会可以来这边打电动实况。OK，
所以到时候如果东西有掉在这边，不一定能够捡得回来哦。所以请大家离场的时候千万不要用任何的个人物品哦。2点钟清洁公司进来清场之后，我们就真的会找不回来了。所以请大家一定要把东西都收整齐、收干净。